Okay, so this is video number 3. So just to revise what we did in video number 2, we were looking at the equation of a circle, but if this was the x and y axis, the center of the circle was always at this point here, 0, 0. And then this is our circle here. And then let's say the circle had a radius of 7. And we want to find the equation of that circle. So we said that this was easy because the center is on 0, 0. So the equation must be in the format x squared plus y squared is equal to r squared. And then because the radius is 7, it will be x squared plus y squared is equal to 49. So today now we are moving on to these type of circles where the center of the circle is not on 0, 0. So here's 0, 0. This is the x and y axis. So today we're looking at circles and how to find the equation of the circles where the center could be out here, not on 0, 0. So once again, just like everything in this chapter, there is a different type of formula for these type of circles. So the equation formula for a circle whose center is not on 0, 0 is this here. X minus h to be squared plus y minus k to be squared is equal to r squared. So in this one here, r is still the radius, but now we have h and k is the center point. So this is the equation to use now if you're dealing with one of these type of circles where the center is not on 0, 0. So it's very simple to do. If we have a look at this circle here, okay, to find the equation, once again, we just fill in this formula here. So it will be x minus, h is the x value of the center, so x minus 4 to be squared plus y minus 6 to be squared is equal to, and then the radius squared, all right, will be 9. And that is your final answer. You do not need to multiply out these brackets, okay? But that is the equation of that circle. Let's go down here to this circle. Okay, so once again, this circle is not on, center is not on 0, 0. So once again, the equation that we're going to be using is x minus h to be squared plus y minus k to be squared, is equal to r squared. So again, we just need to fill it in, but you have to be careful because you can see here it's x. Now the formula says to minus, but the h is already a minus, so that's going to go to plus 5 squared plus y, and then here be careful as well because this is a minus k, but it already is a minus, so that's going to go to plus 4 is equal to the radius squared, but we can see there the radius is 16. So that is the equation of that circle there. So basically in here, to go over it again, this is only used if your circle is not on 0, 0, or the center is not on 0, 0. This is what the equation looks like. H and K is your center point, and then R is your radius. Okay, so if we were to have a look at these circles here, okay, and what I'm going to do is we're going to write down what the radius is and what the center of each circle is. So if you look at this one here, the center, okay, is this thing here, h and k, these two numbers. But you have to remember that in the formula, they were minused. So if we look here, the 4 and the 6 were positive, but when we put them into the formula, they turned negative. If we look down here with this question, the minus 5 and minus 4 was the center, but when we put them into the formula, they went to plus. So it's actually the opposite. So if we look down here, it means that the center of this circle here is actually going to be 3 minus 7. And this thing here is r squared, so the radius of this circle has to be 5. If we look at the next one, the center of this one here is clearly going to be minus 10, 4, because we changed the signs. And then the radius, so this 21 represents r squared, so the only way of getting the radius, it is the square root of 21. We move over to these two here. We have just x squared on its own. There's no number in with it. So that must mean that the center of this circle here is actually going to be 0. And then here there's a plus 4, so that must mean minus 4. And then the radius is going to be, that's r squared is that 10, so the radius is going to be the square root of 10. And then finally then this one here, the center is going to be, well, this here will be minus 3. And then there's nothing with the y, so that must be minus 3, 0. And then the radius then is going to be the square root of 17. So all of this here is for these type of circles, circles that do not have a center on 0, 0. The center is somewhere around one of the quadrants, and the formula that you use for these type of circles is always going to be that formula there. Okay, so I'm going to get you to try this question here, so I'm going to get you to pause the video now in a second and try this question. So it says find the equation of the circle below, and it tells you that AB is the diameter. So if AB is the diameter, it means that the center of the circle must be somewhere on it. So you need to find the equation of that circle. So I'm not going to say anything, I'm just going to let you try it. So you pause the video now, and then when you have it tried, you can start playing it again. Okay, so to do this one here, as I said in the last video, to find the equation of a circle you need two things. The first thing you need is the center, and the next thing you need is the radius. Right now we don't have any of those things. So I'm hoping that you can see there, to find the center, okay, you are just going to use the midpoint formula, because obviously the center is the midpoint between these two here. So to find the center, I'm just going to use the midpoint formula. So it's x1 plus x2 all over 2, and y1 plus y2 all over 2. And then this will find the midpoint first. So if we put it in, okay, again we label it x1, y1, x2, y2. So it's going to be 2 plus 6 all over 2, and then minus 3 minus 8 all over 2. So our final answer there is going to be 4, and then that's going to be minus 11 over 2. So it is okay to get fractions as our answer. So our center point there now is going to be 4 and minus 11 over 2. So that is our center point. So now we know our center. All right, and now we know a very important piece of information. Now we know that the center is not on 0, 0. Okay, so we would not be using this formula, because I said in the last video that formula there is only for a circle that has a center on 0, 0. So we're not going to be using that. We're actually going to be using this one here, x minus h to be squared plus y minus k to be squared is equal to r squared, because this is the formula that we use when the center is not on 0, 0. Okay, so we have the center, and the next thing that we would have to do is find the radius. Now I'm going to skip this because I'm hoping that it's quite easy. To find the radius, you would need to find the distance between the center point, which is here, and this point, or the center point here and that point. So you're just using the distance formula again. And if you do use the distance formula, all right, you get that the distance between any of them here turns out to be the square root of 41 all over 2. So that means that that's actually our radius as well. So now we know everything. Now we know the center, okay, is 4 and minus 11 over 2. And we know that the radius is the square root of 41 all over 2. So now we know everything. So now to find the equation, I can just simply fill in this thing here. Again, h and k is our center point, and r is the radius. So basically, just to get the final answer now, I'm just going to fill in this formula. So it's going to be x minus 4 to be squared. Okay, h is my 4, plus y is going to be plus 11 over 2. Again, 11 over 2 here was a minus, but the formula says to do a minus, so that changes it to a plus. And then that's equal to the radius squared, but we know that the radius is the square root of 41 all over 2, so we have to square that. So then finally, just to tidy it up a little bit, it will be x minus 4 squared plus y plus 11 over 2 squared. I forgot to square there. And then if I square this, that's just going to go to 41, because the square root of a square of a square root, just they cancel, and 2 squared then is going to give you 4. So that is now the equation of that circle up there. So just a couple of very important points here, right? To find the equation, you need two things. You need the center and you need the radius, and then you're either going to use this formula, but this is only for a formula or for a circle whose center is on 0, 0, and this formula here is for these type of circles where the center is not on 0, 0. Okay, so the next question I want you to try is this one here. So find the equation of a circle with a center of 5 minus 2 and having the line 3x minus y plus 4 is equal to 0 as a tangent. Okay, so I'm going to get you to do all of this yourself, including to draw the diagram. So once again, pause this video and give the question a go, and then play it again, and I'll go through it. Okay, so here is the solution to this question here. So as you can see, I just drew my diagram. So there's my circle, and there is my center, and then this is a tangent. Okay, and that is the equation of the tangent. At the beginning of this question, we had the radius. So I had the sorry, we didn't have the radius. We had the center. So I ticked the center, but we didn't have the radius. But what I'm hoping you're spotting by now is that to find the radius, it really just is this formula here, which is the perpendicular distance from a point to a line. So I filled in that formula just like we have done before, and I found out that the distance was 21 over the square root of 10. And so that means that that is the radius. So once I knew all that information, then I was able to finally fill in my equation formula. Again, remember, we are using this formula because this circle definitely has its center not on 0, 0. So I filled it in. H and K were 5 and 2, and then the radius was 21 all over the square root of 10. So that was the radius squared. And then finally, if you square the radius, 21 squared gives you 441, and the square root of 10 squared will just give you 10. So your final answer then is just x minus 5 to be squared plus y plus 2 to be squared is equal to that. And once again, you don't need to worry about squaring out those equations or those brackets. Okay, so the last question that I want you to do is actually in the book. Okay, so this is in the book here. This is page 299, and it is question 13. So this is a very, very good question just to practice a few things. So the diagram shows 4 circles, each of radius length 5. So each of these circles has a radius of 5. Find the equation of the circle whose center lies in the 4th quadrant. So if you remember in trigonometry, this one is the first one, then we go, this is the second one, third one, fourth one. Do you remember in trigonometry we would have cast, C-A-S-T. So this is the first quadrant, this is the second one, this is the third one, and this is the fourth one. So they want you to find the equation of the circle whose center lies in the 4th quadrant. So they want you to find the equation of this circle, and then calculate the area of the shaded region and explain your reasoning. So this is the shaded region here. So what I want you to do is pause this video, okay, and go and get your book and try this question, and then come back to the video, and I will do out the question when you come back to the video. Okay. Okay, so here to do this question, I have drawing quite a bad diagram, but it'll do, of the situation here. So what did they tell us here? They told us that the radius of each circle was 5. So the radius of each circle, so it's 5 everywhere if you think about it, right? The radius of each circle is 5. So they told us all of that. And the first thing that they wanted is they wanted us to find the equation of this circle down here in the 4th quadrant. So once again, the most important thing in this chapter is what are the two things you need to find the equation of a circle? You need the center and you need the radius. Right now it looks like we don't have either of them. But again, you just need to hopefully get lucky and think about these things in honours maths. We actually do have the center. If you think about it, we're coming out 5 there, 5 there. So we're coming out 10 in total. And then if you think about it, we're coming down 5 and 5. So we're coming down 10 in total. So it would make sense that that point there is actually out 10, down minus 10. So we actually do have the center. It is out 10, down minus 10. And then we do have the radius. I suppose we always have the radius. The radius of each of these circles is 5. So we do know the radius. So now that we know the center and the radius, now we can find the equation. So once again, this equation, or this circle here, is not on 0, 0. So once again, the equation is going to be in this format. And now we just need to put in the numbers. So it's going to be x minus 10 to be squared plus y plus 10 to be squared is equal to 5 squared, which is going to give you 25. So that is part I done. That is the equation of the circle. The next part, part II, they want you to find the area of this kind of blue region here, which can be a little bit tricky. But if you think about it, right, if we can't find the area of this, all right, this is not a shape. This shape here, okay, there's no formula for the area of this shape. So once again, you just need to be kind of smart about it. What I do notice here is there is a perfect square here. Okay, that square there. And that square there, so this going right the way across here is 10. And the going right the way down here is 10. So that full square there is a 10 by 10 square. So the area of the full square that I'm shading in now is 100. The area of this full square here is 100. But we don't want the full square. We don't want these white bits here. We just want the blue parts. But if you think about it, that white part, this white part, that one and that one, they are all quarter of a circle. So they would all come together to make a full circle. And how do you find the area of a full circle? Well, the formula is in your log tables. It is pi r squared. All right, so to find the area then, that's going to be pi, or you could write 3.14, it doesn't matter, multiplied by the radius squared, which is 25. And the answer to that is 78.5. So the area of all of these white parts is going to be 78.5. And then to find the area of the blue part, it's obvious, we obviously just get the whole thing, which is 100. We take away 78.5, and that gives us an answer of 21.5. I can't remember what our units were, but if they were centimeters, it would obviously be centimeters squared. So that is the solution to that question there.